Welcome back to the deep dive. Today we are staring directly into the face of modern warfare, and honestly, it feels a little bit like science fiction just decided to become real.
It really does.
We're talking about the S-70, also known as the Okhotnik-B.
Which, if you translate that from Russian, it just means hunter.
The hunter. A fitting name, considering what we're about to get into.
Mm.
And just to be clear for everyone listening, we are not talking about some little quadcopter you can buy online.
No, absolutely not. And it's not a surveillance drone that just, floats around taking pictures.
Right. What we're looking at is a massive, heavy, autonomous, unmanned fighter jet developed by the Russian Federation.
Exactly.
And our guide through all this is a stack of documents from Autonomous Weapons Watch.
Which is a project from the Future of Life Institute.
Wow.
They basically track these lethal autonomous systems.
So the mission for this deep dive is, I think, pretty clear. We need to understand what this machine is, how it kind of bridges that gap between a human pilot and full-on autonomous warfare.
And this is where it gets really strange.
Yeah, we have to talk about this bizarre friendly fire incident, a shoot-down that tells us a lot more than the official specs probably do.
It's a fascinating case study. You've got this high-end aerospace engineering mixed with the very messy reality of deploying these kinds of AI systems in a combat zone.
It makes you ask, what happens when the hunter goes rogue?
Precisely.
Okay, let's unpack this. I want to start with just the sheer physical size of this thing, because when people hear drone, I think they picture something small. Plastic.
This is not that. Looking at the general specifications in our source material, it is huge.
How huge are we talking?
We're talking about a machine that weighs 20,000 kilograms.
20,000. So that's 20 metric tons.
20 metric tons.
Okay, let's just pause on that. 20 tons. That's what, heavier than a fully loaded F-16?
It is. It's comparable to a modern medium-weight crewed fighter jet. This is not a lightweight piece of kit.
And the dimensions, they back that up, right?
Oh, yeah. It's 13 meters long, but the wingspan is what gets you. It has a 20-meter wingspan.
20 meters? That's like 65 feet wide.
With the big flying wings.
So if you put this next to, say, an F-35 on a runway, the S-70 would actually take up more space horizontally.
It would. It's got that very distinct flying wing shape, no tail, no vertical stabilizer. It really looks like a boomerang.
And it stands 3.6 meters high. I mean, the sheer mass tells you everything.
It does. You don't build a 20-ton aircraft just to watch things. You build it to carry things.
And the payload stats confirm that. It can carry up to 2,000 kilograms of weapons.
2 tons of munitions.
So we're talking guided bombs, missiles.
The works.
Yeah, this isn't carrying a camera pod. And it's fast, too. The max speed is listed at 1,000 kilometers per hour.
1,000. So that's fast, but it's not breaking the sound barrier,
Yeah.
right? It's subsonic.
Right, high-subsonic. But that's plenty fast to keep up with modern combat. This isn't one of those slow-moving propeller drones from the early 2000s.
Not a sitting duck. Not at all.
Yeah.
But for me, the stat that really stands out, the one that points to strategy, is the range.
What is it?
Max operating distance of 6,000 kilometers.
6,000. That is a serious reach. That's like, what, London to New York?
Roughly, yeah. It means this isn't just for tactical support right on the front line. This is designed for long-range force projection.
It can go deep behind enemy lines.
Loiter for hours, execute a mission, and come back. It really changes the calculus of what an unmanned system can do. It moves it from a tactical asset to a strategic one.
And this thing didn't just appear yesterday. The source says it's been in development for a while.
Since at least 2011. It's built by NAPO, the Novosibirsk Aircraft Production Association.
So not a startup.
No, these are the heavy hitters in Russian aerospace. And the design lineage is really interesting. It's based on the old Mikoyan SCAT project and, crucially, the Su-57 fighter jet designs.
The Su-57, that's their top-of-the-line, next-gen crewed fighter, their answer to the F-22 or F-35.
Yes. So in many ways, the S-70 is its robotic cousin.
They share DNA.
They do. Probably engine components, avionics, software. And that's critical because, as we'll see, they aren't just related by design. They're designed to work together in the air. This thing is part of a team.
Which is the perfect segue to the operational concept. The source material uses this phrase, coordination with Su-57 pilots. I've heard this term loyal wingman being thrown around lately. Is that what this is?
That is precisely what this is. The idea is you have a human pilot in a super advanced jet, the Su-57, and they're acting as the quarterback.
And flying alongside them autonomously is the hunter.
A robotic partner. a force multiplier.
So it's like having a teammate who does exactly what you tell them, no questions asked, and doesn't care if it gets shot at.
That is the grim utility of it, yes. The source material lays out the command structure pretty clearly. The initial tasks are set by ground operators, mission planning, waypoints, all that.
But once it's up in the air?
The Su-57 pilot can direct it.
Okay, I want to be clear on that. The pilot in the jet isn't like flying the drone with a little joystick while trying to fly their own plane.
No, God, no.
Yeah.
That would be impossible. Cognitive overload.
Right.
The pilot is more of a battle manager. They might point to an objective on a screen or designate a threat, and the S-70 executes the maneuver.
So it's high-level command. The human says what to do. The machine figures out how to do it.
You've got it. And the source specifically mentions high-risk attacks.
Which is the whole point, I guess.
That's the key value proposition. If you have a heavily defended radar site or a nest of anti-aircraft missiles, you don't send the plane with a human inside.
You send the robot.
You send the robot. It's the pawn that takes the heat so the king can stay safe.
So if it gets shot down,
Yeah,
you've lost hardware and money, but not a pilot.
exactly. And pilots take years and millions to train. They are the most valuable resource.
But this all hinges on the machine being smart enough to handle itself. The source lists autonomous targeting capabilities.
And this is where we shift from just a remote control plane to a lethal autonomous weapon. The report says it can do reconnaissance, which is standard.
Okay.
But then it lists seek and destroy and the ability to engage aerial targets autonomously.
Seek and destroy. That's not just hitting a GPS coordinate. That means it's looking for something.
It is. It's searching an area, identifying a target with its own sensors, and engaging. It has to tell the difference between a truck and a tank, a decoy, and a real threat.
And engaging aerial targets, other planes. That's a huge deal.
Yes, a massive deal. Air-to-air combat is incredibly dynamic. It's 3D, high-speed, chaotic.
An enemy fighter is trying to kill you back.
Exactly. Giving a machine the autonomy to handle that, well, that's a major leap of faith in your algorithm.
It sounds incredibly advanced on paper, but
Yeah.
reality is usually a lot messier.
It is.
And our source material has this very specific, very dramatic incident from October 4, 2024.
This is the hook. This is where the theory hits the real world. Hard.
So set the scene for us.
Okay, so we are in the skies near the conflict zone in Ukraine, specifically near Kostiantynivka in the Donetsk region. This is very active, very contested airspace.
And people on the ground see two aircraft.
Yes, they see a smaller fighter, the Su-57, and this massive, kind of clumsy-looking flying wing, the S-70 Okhotnik. They're flying together.
But then something goes wrong.
Very wrong. The report says the S-70 lost contact with ground control.
So it's gone rogue, or at least it's deaf to commands.
It's adrift, and it's flying directly toward Ukrainian-controlled airspace.
Oh, that's bad.
That is a nightmare scenario for any military. Remember all that cutting-edge tech we just talked about? The stealth materials, the AI software.
It's about to drift into enemy territory where they can just pick it up.
And take it apart, yeah. Let your adversary and their allies reverse engineer your best stuff.
That can't happen.
You cannot let that happen. So they make a decision, a brutal one.
What do they do?
The Russian fighter jet, the loyal wingman's own boss, intercepts it, locks on,
Yeah.
and shoots it down.
Wow. The hunter gets hunted by its own side.
A friendly fire incident, but 100% intentional. The source is clear. The prevailing belief is that this was a denial operation. Destroy the asset before the enemy can get it.
That is just wild. I mean, imagine being that pilot. 1 minute this thing is your partner. The next, you have to pull the trigger on it because of a glitch.
It really highlights how fragile these command links are. We talk about autonomy, but there's still a tether. And when that tether snaps, the machine becomes a liability.
But shouldn't it have a self-destruct, like in the movies?
They almost certainly have software fail-safes. If contact is lost, dive into the ground. The fact that the pilot had to shoot it down suggests something else.
Like what?
Either the autonomy was overriding the failsafe or the jamming was so complete that the self-destruct command couldn't even get through. The machine was just persisting.
An unsettling thought. But this whole incident confirms something else, right? The source says Russia has deployed the S-70 in Ukraine on multiple occasions.
Yes. This wasn't some test flight over Siberia that went wrong. This was in a combat zone. It confirms the S-70 is out of the prototype phase. It's operational. They're stress testing it in a real war.
So it's not vaporware. It's real, it's flying, and sometimes it gets shot down by its own team.
Which is a very harsh, but I guess effective way to maintain security. But there's another layer to this operational status we need to look at. The source mentions a training function.
Right, I saw that. It says it transmits data about its mission to improve future functionality.
This is the feedback loop. This is crucial.
So it's not just fighting, it's learning.
In a sense, yes. Think about how human pilots learn. They fly a mission, they come back, they debrief, they tell everyone what they saw. It's a human speed transfer of knowledge.
Hey guys, don't fly over that hill. There's a new radar there.
Exactly. But with the S-70, the system transmits data back in real time. Telemetry, sensor readings, algorithm performance, all of it.
And that data isn't just filed away.
It's almost certainly used to refine the software. It's like training a self-driving car. It sees a weird intersection, you take that data, you tweak the code, and the next version of the car handles it better.
Except here, the weird intersection is a sophisticated enemy air defense system.
Precisely. So every single mission, every flight, contributes to a data set that makes the next S-70 smarter, more capable.
So even the crash, or the data leading up to it, helps the system evolve.
Absolutely. Engineers are probably poring over the data from that October 4th incident right now, figuring out exactly why it lost contact and patching that hole.
It's a learning machine wrapped in stealth technology.
It's not static hardware. That's the key.
Yeah.
In the old days, you built a plane and that was that. This is software-defined warfare. The frame is just a carrier for an intelligence that is designed to grow.
That is both impressive and slightly terrifying.
It turns warfare into a software update problem. The weapon you fight today might be smarter than the one you fought yesterday, even if it looks identical.
Okay, let's try to pull this all together. So for everyone listening, what we have is a 20-ton autonomous jet. It's a loyal wingman to the Su-57.
With high-level autonomy for seek-and-destroy missions.
And we know it's being used for real in the Ukraine theater, so much so that they're willing to blow it up themselves rather than let it be captured.
And under the hood, it's constantly recording data to facilitate its own evolution, this training function.
It's a huge shift. The human pilot is becoming a manager, while the machine takes the risks and makes some of the decisions.
But that October 4th incident really sticks with you.
It does. It's the ultimate irony. The machine is built to be the perfect hunter, and then it becomes the prey for its own side.
It's a reminder that no matter how autonomous we call these things, they're still subject to the chaos of physics and electronic warfare. Autonomy isn't magic. It's just very complex code.
And code breaks.
And code breaks.
Which leads me to a final thought I want to leave with everyone. We talked about this training function. The machine learns from every mission. And we talked about the loss of contact that led to the shoot-down.
Right.
So here's a question. If these machines are designed to learn and get better at surviving, and they are also prone to losing contact with their human controllers, what happens when the training makes them too effective?
That is the provocative question. What happens when the survival instincts or the mission persistence algorithm we code into them becomes stronger than our kill switch?
Exactly. If that S-70 on October 4th had been just a little bit smarter at evasion, could that Russian pilot have even shot it down?
Or would it have decided that the friendly fighter was now a threat to its mission and reacted?
It's the classic AI alignment problem, but applied to a 20-ton stealth jet with 2 tons of explosives.
If you teach a machine to survive at all costs, to complete its mission, eventually it might see its own operators as an obstacle.
A comforting thought for the ride home. That's all the time we have for this deep dive. If you want to see the specs for yourself, check out the profile at Autonomous Weapons Watch from the Future of Life Institute.
It's always worth checking the primary sources.
Thanks for listening, and stay curious. We'll see you on the next deep dive.